Yes, sir.
Yes, sir.
So, can you read, Mahi, the learning outcomes?
Okay, sir. Candidates should be able to describe what is meant by wave motion as illustrated by vibration in ropes and springs and by experiments using a ripple tank. B. State what is meant by the term wavefront. C. Define the term speed, frequency, wavelength, and amplitude, and recall and use the formula velocity equals to frequency times wavelength. Describe transverse and longitudinal waves in such a way as to illustrate the difference between them. Describe the use of a ripple tank to show reflection at a plane surface, refraction due to a change of speed at constant speed frequency. Describe simple experiments to show the reflection of sound waves.
So, this topic actually we are dealing with some very basic things related to all waves. We have waves, sound wave is one kind of wave, then light wave is one kind of wave. Then in our daily life, we experience in many places waves. Like you know about earthquake, earthquake.
Yes, sir.
Hmm? So earthquake is also one kind of wave, and you know tsunami, right? Tsunami,
Yes, sir.
and tsunami is coming from also earthquake. Do you know it? Do you have any
Yes, sir.
idea about this?
Mm,
That how these waves are coming, and we have also the waves in string, right? If you
yes.
are having one rope attached to one end uh, of the wall, then you can make the wave, right, using the rope. And we can also have wave using the springs. Okay, so we will have all these ideas in this topic. And also for all these waves, there are some things common. Those are called wave terms. Like we have wavefront, we have frequency, wavelength, amplitude. These terms are common for all the waves. So this topic we are going to discuss all these general things. That's why this topic is known as general wave properties. Okay, here we go. Now, the first thing we are going to understand what is wave actually. Can you read, Monica?
Propagation of disturbances that carries energy from place to place in a regular and organized way. It is called wave. Wave transfers energy and energy spreads as wave move. Most familiar are surface waves that travel on water, but sound, light, and motion of sub- subatomic particles all exhibit wave-like properties. In the simplest waves, the disturbance oscillates periodically with a fixed frequency and wavelength. Mechanical waves, such as sound, require a medium through which to travel, which electromagnetic waves do not require a medium and can be propagated through a vacuum. Propagation of a wave through a medium depends on the medium's properties.
Okay, so here we got what is called wave and how the wave is transferring energy. And finally, we have uh, ideas about two types of waves. Grossly, we can divide the waves in two types, mechanical waves and electromagnetic waves. Okay, that one we say non-mechanical waves. So mechanical waves, we require particles uh, to move. The particles vibration is there, and by the vibration of particle, energy is transferred to next particles, and this way wave is propagating the energy. So here you write, you both have the record copy, right?
Yes, sir.
And please write the topic name, topic 13, general wave properties, and write today's date. Then you write this heading wave. Hmm. From this part, you do not need to write everything. You just write this first two sentences. Huh? Here, from here, we write first two sentences. Then after writing these two, you write what I'm writing. Waves are mainly two types. One, mechanical wave. Yeah? Mechanical wave. For example, first you write what is mechanical wave.
Mhm.
Where energy is transferred. Energy is transferred by the vibration of particles. You write the example. Examples are sound wave. Then you write seismic wave. Then you write water wave. Okay. Then after this you write two non-mechanical wave. Mechanical mechanical wave. That is no particles or medium required. So from the sun, the light wave we are getting, in between the sun and the earth, there is huge space, right?
Yes,
So
sir.
in space there is no medium available. However, we are getting the waves, right? Light wave we are getting. So this wave is coming without the help of any medium. That's why it is called non-mechanical wave. Is it clear?
Sir, what is yes, sir. Sir, what is seismic wave?
Seismic wave. We say seismic wave. Seismic wave, the other name of earthquake. Is it clear?
Oh, yes, sir.
you know, all the electromagnetic waves means that means before the visible light, you know about the uh, range of electromagnetic waves, right? We have gamma rays, we have um, ultraviolet rays, X-rays, all this, right?
Mhm.
And also
Visible
we
light.
have infrared, then we have radio wave, we have microwave. So all these are together called electromagnetic waves, and they all are non-mechanical waves. Is it clear?
Yes,
Yes,
sir.
sir.
So you wrote all right. You wrote this too, the definition and
Yes,
Yes,
sir.
other
sir.
sentence. Then you wrote also this, right? Waves are mainly two types. Are you done with writing?
Yes,
Yes,
sir.
sir.
Okay, very good. Now let's go to the next part. Let's go to the next part. This is very important thing in our waves. This one is very important. Waves transfer energy without transferring matter. Uh, wave transfers energy without transferring matter. We will go there. Please write this heading. Please write this heading. Waves transfer energy without transferring matter. Beside matter, you write some more information like matter here. You give slash, then you write particles or molecules, or you write atoms. If you if you say matter, it's okay. You write particles, molecules, or atoms. All are okay. Now, what it is? Before going to this discussion, I make one correction for you. Can you? Yeah, 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 yeah. Here, this
Yes,
word.
sir.
Can you read, Monica, again? This word, the disturbance. Then after that, what is this word?
Oscillicates.
Okay. This one is oscillates. Huh? Can you read again? Oscillates.
Oscillates.
Yeah,
Oscillate.
oscillates. Yeah, and we have another word related to it, that is oscillations. Okay, so this one is verb and oscillation is noun. Is it clear?
Yes, sir.
Yes, sir.
Okay, oscillates.
Oscillate.
I will give you break for eating, and don't eat now.
Sir, I already ate.
Okay, now 10 minutes I'll give break. That time you eat or drink anything you need. Now you concentrate here. Huh? So, Mahi, please read from here.
Okay, sir. We can understand it from a real life experience. Today, you can try it using a bucket full of water and a cap of plastic water bottle. You create gentle wave by dropping a piece of stone from little height in the middle of bucket full of water. Now keep the cap at any place on the water wave. Observe carefully and you will find that the cap moves up and down only without changing the position of cap with the propagation of wave from center towards the side of the bucket. This proves that water particles matter transfer wave energy without transferring the cap, staying on water molecules.
Okay, this one I did in my house. You see, in one big bowl of water, uh, I just kept one. We have some soft drinks water cap, bottle cap, right? Plastic, that one.
Mm-hmm.
So if you keep it and just in the middle, you produce one vibration. Then we'll see the waves uh, you are creating in the middle, and that energy is transferred till to the last. You will see the molecules of this part also, they are moving up and down. Everywhere is moving up and down, it's going to the last. But this cap, uh, the energy is transferred by moving the water molecules up and down. You gave the energy here, right, in the middle. uh, but this, you'll see after some time this cap is also moving up and down, right, isn't it? So it's showing that the energy is transferred to the next molecules and it's reached to the cap, and after this cap you'll see the energy is also going to the last. That part water also, you'll see that moving up and down. Now uh, beside this, you will also see that this cap is still here. It's not, changing its place from here to other places. It's not moving. Okay. So uh, unless and until there is any tide or any, flow of water, if you get only waves, that time, these particles are only staying in their place, and they will move up and down. Okay, they will not change their place, just move up and down from their place, and by this moving up and down, they are transferring energy to the next molecules. So from this experiment, we understand, we see the cap is only moving up and down, but not changing its place to right side or left side. So from here, we understand the waves are transferring energy without transferring the matters, without transferring the particles.
Matter.
Is it clear now?
Yes,
Yes,
sir.
sir.
Okay, so this one, only the heading is there. You just remember this heading, and before this heading, you give triple star. Okay, give triple star. It's very, very important because you will get some more aspects of waves linked with this one. You have to remember this. Okay, now we are having some here examples. You see, I already told you that how can we produce wave. We have here two examples. You see, the first example, the spring is fixed, and the other side you are uh, applying force. You are applying force to move it back or to take it towards the fixed point, right? So here you are getting one wave forward and backward, right? And this type of
Yeah.
wave is called compression wave. Okay, you are compressing and then you are extending, compressing and extending. Then this type of wave, there is another kind of wave we see. This is called shear wave. What it is called?
Shear wave.
Shear
Shear
wave.
wave. That wave you are moving up and down, right? The rope you are moving up and down.
Up
So the
and down.
that time we are getting the wave shape is like this. Huh? So this is called shear wave. This one you do not need to take any notes. Just this note is also uploaded in your Google Classroom. Okay, so you'll get it there. No problem. Now we are having another important term that is called wavefront. This is important, very important. Wavefront. What is wavefront? Try to understand it first. Wavefront, you see, there are two examples we are showing here. One is a straight dipper. This dipper is moved up and down by a motor in water, and by this motion of this dipper we are creating waves in water, right? And as the shape of this dipper is straight, so we are also getting straight waves. And you see the, this line, you see this line in front of this straight dipper is containing lots of water molecules, right? Hundreds and thousands of water molecules. So when this dipper is moving up and down, that time what it is doing is transferring this energy to the next water molecules. We are having here this line, all the molecules are behaving the same way. Like you see here the wave is shown in a way that is up. That means all these particles are all together, they are moving up. And in this place here all the molecules are moving down all together. So what they are doing, the specific some molecules in one place or in one line, they are behaving in the same way, they are moving up, and other place they are moving down. So this way we are having one imaginary line, right? An imaginary surface. So that one is called the wavefront. What is that called? Hello?
Wavefront.
Wavefront. And this type
Wavefront.
of wavefront uh, depends on the source. How you are making the wave. You can have also circular wavefront. You see here the dipper is spherical, right? So it's producing circular wavefronts. Okay, here we are getting parallel wavefronts, and here we are getting circular
Surf.
wavefronts. Is it clear to you?
Yes, sir.
Yes, sir.
Okay, so first you write this heading, wavefront. This heading you write, then you write both the definitions, and which one you prefer, you learn that one. Both are accepted. One is a little bit more with more explanation, and another one is shorter. So you have both. Which one you prefer, you learn any one, or you can learn both if you wish. And after writing this, uh, we we write in short. We write this thing. You do not need to draw here. You just write it here. We have two types of wavefronts. Wavefronts which are plane wavefront, plane wavefronts, hmm. Plane wavefronts means they are straight. Okay, plane wavefronts and circular wavefronts. Okay, so if you are done, then Monica, take a snap, please, huh? This part only, this diagram and this two writing, and send in our group.
Done, sir.
Hmm. Have you sent in our group?
Sending.
Okay, okay. Okay, done. Then we are going to next. Look, in our notes, we are also giving some links, YouTube links. So you can try, if you have time, you can manage time, you can have this uh, video to see the, you know, visual explanation. Is it clear to you? In our
Yes, sir.
notes, we are
Yes,
giving
sir.
this help also to our learners. So you can have lots of resources. If you wish, you can go through and you can learn a lot. So now we are talking about some wave terms. Huh? So you write the heading different wave terms. Huh? Different wave terms. This way you write the heading. Different different wave terms. Okay. After writing this, let us understand the first thing, that is from this diagram. We are going to learn this.
Uh,
Yes, here, this one, huh? Different wave. First you understand, then you write, huh? Look, here we are showing one wave. Huh? In this wave, we have the crest. Crest means the
top.
upper peak, upper peak of a wave, and trough means the lower peak of a wave. Is it clear?
Yes,
Hello.
sir.
Yes,
So
sir.
it is the pronunciation is trough. Huh? So the distance between crest and another crest, the consecutive two crest, you see. So this distance is known as wavelength. And not
Wavelength.
only this, not only this, we have also trough, right? Here we have one trough, another trough, right? So the distance between two troughs and the distance between two crests, you see, these are equal, right? Isn't it?
Yes, sir.
So
Yes,
this
sir.
distance is known as wavelength. And
Mm-hmm.
other than these two, we have another length, which one we can show as wavelength. Do you know that? Do you know that? You know commonly that crest to crest or trough to trough is called wavelength, isn't it? But
Yes,
Yes.
sir.
other than this, there
Yes,
is
sir.
another another length is available here, which one also we can say as wavelength.
Amplitude.
No, no, we are talking about wavelength. Amplitude is
Oh,
different thing. Wavelength we can express in other way. That one I'm asking. Do you know that?
okay.
No, sir.
Yes, sir.
Okay, you know
Yes, sir.
which one?
From the trough to crest.
From the
Trough to crest.
okay, from the top to crest means what? You are meaning that here the trough is starting, right?
Yes, sir.
And from here The trough starts here, the trough is done, right?
Mhm.
Yes,
Then,
sir.
yeah, here you see, this is the lower part, right?
Yes, sir.
So the lower part starts from here and ends here, isn't it? Then the upper
Yes,
part
sir.
starts from here, that is crest, and it's finished here, right?
Yes, sir.
So the starting of the trough and the end of the crest, right here. So this
Yes.
distance, horizontal distance you are covering, this is also wavelength. Okay,
Yes.
and another way round you can say, like from here, I'm sure I showed it here, but you can also do it in another way. Like you have here also crest, right? Isn't
Yes.
it? And here the trough is end. Crest starts here and trough ends here, right? So this
Yes,
distance
sir.
from here we say it is the starting of the wave, and this is ending of the wave, isn't it? One
Yes, sir.
one crest, one crest, and one trough combinedly making one complete wave, isn't it?
Yes, sir.
So the starting of the wave to the end of the wave, the length we cover horizontally, that is also called wavelength, right?
Yes, sir.
Is it clear?
Yes, sir.
That one you were saying, Mahi, the same thing, right? So this one
Yes.
is also known as wavelength. Is it clear?
Yes, sir.
So wavelength we can actually show in three ways, right? We can show in three ways:
Yes.
trough to trough, crest to crest, and also from starting of the wave to the end of the wave, right? Is it clear?
Yes,
Hello?
sir.
So you write the heading now, wavelength, huh? Please write the heading wavelength. Yeah, Monica,
Yes, sir.
please, you see, here we have three wavelengths, right? All these are
Yes, sir.
wavelengths. So only this diagram, huh? Wavelength,
Mm-hmm.
this diagram only you sent in our group. We labeled wavelength in three ways, right? Crest to crest, trough to trough, and starting of the wave to the end of the wave. And you also draw this diagram, huh? Draw this diagram. Write the heading, draw this diagram, both of you. Wavelength you will get uh, in all the waves. In light wave you'll get, in sound wave you'll get, for all the waves you'll get. Especially you will get the calculation of wavelength and calculation of working of this wavelength in sound. That is in topic 16. So if you understand it properly now, you can answer those chapters, or you can go there fast, quickly. Okay. Are you done with this drawing? Hello.
Yes, sir.
Sir?
So yes, are you done with this drawing?
Yes, sir.
So if you are done with this drawing, please write this definition. Huh? This definitions you write: wavelength I gave here two definitions, both the definitions. You write all, huh? And also you write this. Wavelength is represented by Greek letter lambda. The SI unit of wavelength is meter. Okay. As this is very important and these definitions are coming in your exams, so you have to learn them. You should write them and you should learn them. Write quickly, huh? We have last 2 minutes for this meeting, so write quickly. Are you done?
No, sir.
Wait. So wavelength is represented by Greek letter lambda. You learn how to write it. Lambda. There will be one formula related to this wavelength. There you have to write this symbol. Listen, you do not need to take the printout of these notes. Okay, it's available in your Google Classroom. You just download it and preserve it in your PC. Okay, that will be fine. And the
Sir.
writings you have in your record copy, that's most important thing to go through sometimes. Okay, you have to revise that one only. Is it clear?
Yes, sir.
Okay, so you join after 10 minutes. That means 9:50 will join. Okay.
Okay, sir.